The first step in the Denavit-Hartenberg method is to assign frames to the kinematic diagram. We did this in Robotics 1 already, so we won't spend too much time on this. I am going to just review the rules for you here and try to clear up some of the more commonly made mistakes. If you are watching this through our course website, robogrok.com, there is a link to the video on this topic from Robotics 1 right over here. Before we start looking at the 4 Denavit-Hartenberg frame rules, there are a couple of preliminary rules. First, remember that we need to have a minimum of 1 frame for every joint plus 1 frame on the end effector. Note that it is okay to have more frames than this, and sometimes it can even be very useful to have more frames. But you can't have less. For example, if your kinematic diagram has 3 joints, you need to have at least 4 frames. If your kinematic diagram has 5 joints, you need to have at least 6 frames, and so on. The second preliminary rule has to do with how we draw axes so that another person can understand what we're drawing. This rule is that there are exactly 6 ways we can draw an axis: up, down, right, left, diagonally in the first quadrant like this, and diagonally in the third quadrant like this. When we draw the axis in the first quadrant, that means that the axis is going into the page or into the screen. And when we draw the axis in the third quadrant, that means that the axis is coming out of the page or out of the screen. We can't ever draw axes in the second or fourth quadrants like this, because then it is not clear which direction they are going. I will always use this convention, and I expect you to use this convention in your submitted work also. Now, when you are assigning these frames, you need to follow 4 Denavit-Hartenberg rules. I am going to start by telling you what all 4 rules are, and then I'll give you some examples to try to help you understand what they all mean. Here are the 4 rules. 1. The z-axis has to be the axis of revolution for a revolute joint, or the direction of motion for a prismatic joint. 2. The x-axis has to be perpendicular to the z-axis of the frame that comes before it. 3. The x-axis has to intersect the z-axis of the frame that comes before it. And 4. The y-axis has to be drawn so that the frame follows the right-hand rule. That's it. We have 1 rule about the z-axis, 2 about the x-axis, and 1 about the y-axis. Let's look at some examples. Suppose you have a kinematic diagram that looks like this. First, we can see that we need at least 4 frames on this diagram because we need 1 frame for each joint, plus 1 on the end effector. Now, let's apply Rule 1. For the rotational joints, z has to be the axis of revolution. That is, the axis that the joints are rotating around. Now, keep in mind that it doesn't matter which way is positive. In other words, I could have drawn z0 down instead of up. I could have drawn z1 into the page rather than out of the page. For the prismatic joint, z has to be the direction that the joint moves. For a prismatic joint, this direction is indicated by the positioning of the square next to the cube. So z has to be either to the right or to the left. Now, how do we draw the z-axis on the end effector? As we go through these rules, we will see that there are some cases where the rule doesn't really apply. Anytime the rule doesn't apply, the direction of the axis is our free choice. So here, I could draw the z-axis in any direction I want. If I draw it in the same direction as the last z-axis, my math will be simplified in future steps. But this isn't an actual rule. You can draw the z-axis any direction you want here. Okay, so we're done with Rule 1. The z-axis must be the axis of revolution or the direction of motion. Let's move on to Rule number 2. The x-axis has to be perpendicular to the z-axis of the frame before it. When we apply this rule to the 0 frame, this is another case where the rule doesn't really apply. There is no frame before the 0 frame. So I could draw the x-axis any allowable direction, to the right, to the left, into the page, or out of the page. Of course, I can't make x go up or down, because then it wouldn't be perpendicular to its own z-axis. So I will choose to draw it to the right here. Now, when we draw the x-axis for frame 1, we don't have as much freedom. I need to follow Rule 2 here. Rule 2 tells me that the x-axis has to be perpendicular to the z-axis of the frame before it. In other words, x1 must be perpendicular to z0. So I can't draw x going up or down, because that would not be perpendicular to z0. Of course, I also can't draw x going into or out of the page, because in a coordinate frame, all axes have to be perpendicular to each other, and z1 is already coming out of the page. So that leaves me with only two options. I can draw x to the right or to the left. Here, it doesn't matter which direction you choose. I will draw it to the right. Now, let's apply Rule 2 to the 2 frame. Rule 2 tells me that x2 has to be perpendicular to z1, which is the z of the frame before it. This means that x2 can't be coming out of the page or going into the page, because that would be parallel with z1, not perpendicular to it. I also can't make x2 be right or left, because that would be parallel to its own z-axis. So I am left with only two options, up or down. It doesn't matter which you choose. I'll choose up. Okay, finally let's apply Rule 2 to frame 3. I have to draw x3 so that it is perpendicular to z2. So I can choose up, down, into the page, or out of the page. I'll choose up because I know that anytime I can keep the axis directions the same as the last frame, my math in the end will be simpler. Okay, so now we've gone through two rules. 1, z must be the axis of rotation or the direction of motion, and 2, x must be perpendicular to z of the frame before it. Now on to Rule 3, which also has to do with the x-axis. The x-axis must intersect the z-axis of the frame before it. This is the hardest rule of all four, so I'm going to spend a little time explaining the rule before applying it to this manipulator. When we draw axes in a coordinate frame, we draw the axes like short sticks with an arrow on the end. But really, the axis goes on forever in both directions, like a number line. Now, if we are drawing lines in 2 dimensions on a plane, there is only one way for two infinite lines to not intersect, and that is if they are parallel. If the two lines aren't parallel, they will intersect somewhere. But when we draw lines in 3 dimensions, that isn't true anymore. We can have lines that are not parallel but still don't intersect. That will happen if one line goes above or below the other line. In fact, in 3 dimensions, 2 lines could even be perpendicular to each other and still never intersect, because the 2 lines don't lie on the same plane. That's why we need to have this third rule in addition to the second rule. The second rule tells us that each x-axis has to be perpendicular to the z-axis of the frame before it. And the third rule says that the x-axis also has to intersect the z-axis of the frame before it. So now suppose that you have 2 lines in 3-dimensional space, and suppose that these 2 lines are perpendicular, but they don't intersect, because one line passes above or below the other line. How could we change the lines so that they stay perpendicular, but also intersect? It turns out that there are 2 ways to do this. One way is to rotate or change the direction of one of the lines until it hits the other, like this. The second way is to translate one of the lines until it hits the other, like this. When we apply this to our robotics kinematic diagrams, we are always going to try to use the first option, rotate the line, first. Only if we can't make the lines intersect that way will we try the second way, translate the line. Let's apply this rule to our kinematic diagram. For frame 0, Rule 3 doesn't apply because there is no frame before it. So we're okay here. Let's move on to frame 1. Rule 3 says that x1 must intersect z0. Now we need to use our imagination here a little bit because our drawing is in 2 dimensions, but this manipulator is actually in 3 dimensions. To help us picture this drawing in 3 dimensions, I've made a 3D model of this drawing. Let's take a look. Here's x1, and here's z0. If x1 extends out forever in both directions, will it intersect with z0? It will. So that means that Rule 3 is obeyed here. What about for frame 2? If x2 is extended out in both directions, will it intersect with z1? It will not. It will pass in front of z1. So how can we fix this? Well, we learned previously that we have 2 options. We can either change the direction of x1 or we can move the whole line, which means that we have to move this entire frame. We always want to start by trying to change the angle or the direction of x. Could we do that here? Yes, if we rotate the whole frame like this. But if we did that, we would violate the first rule about the z direction, so we can't do that. In this case, there is no way that we can rotate the frame to get the third rule to be followed. So we'll move on to the second way to solve the problem. Move the frame. In what direction should we move the frame? It turns out that there is an easy way to figure this out. We draw a line from the z1 axis to the x2 axis in such a way that the line is perpendicular to both z1 and x2. Then we slide the whole 2 frame along this line until x2 does intersect z1. Now, it's important to keep in mind that frame 2 is still attached to the prismatic joint. Even though we have moved the frame so that it is on top of this second revolute joint, we haven't changed how the frame is attached to the manipulator. For example, when the second revolute joint rotates, the 2 frame is going to rotate also as the prismatic joint rotates and moves through space. Frame 1 won't rotate as the second joint rotates, but frame 2 will, because frame 2 is still physically attached to the third joint, even though it's positioned at a different location in space. Now, we need to check on the end effector frame also. It's important to make sure that all the frames, even the frame on the end effector, follow all of the rules that apply. So does x3 intersect z2? It does. So we're done with Rule 3. Rule 4 is much easier than Rule 3, thankfully. This rule says that we have to draw the y-axis so that the whole frame follows the right-hand rule. The right-hand rule can be expressed in a number of different ways, but this is the one that I think is easiest to use. Lay your right hand totally flat with your thumb sticking straight out like this. Put your fingers pointing in the x direction and put your thumb in the z direction. Then the direction that your hand is pushing, the direction of the palm of your hand, is the y direction. Let's add y-axes to our drawing. Getting good at drawing frames on kinematic diagrams mostly requires practice. If you feel uncomfortable with this topic, make sure you do the interactive practice before you take the quiz today. If you feel okay with this topic, we'll move on to the next video where we will create the DH parameter table.